In lesson 40, we'll be covering operations with numerical representations of functions. And numerical representations of functions, that normally involves a table of xy pairs at some point. And then from that, a symbolic or graphical form is identified, one of those other two forms that a function could be in. The fourth form being a verbal form or word problem. Well, numeric forms, those are less frequently encountered in mathematics. They're often foundational to a researcher's work, like a scientist or an engineer, somebody who's collecting data. Collecting experimental data is frequently collected in a tabular form, in the form of a table. So then the data is plotted on a graph, analyzed to determine if it can be modeled using a function, things like that. So problems here in lesson 40, they'll give you experience working with numerical forms, studying tables, performing composite function operations also. Look at example 1 here. Given f of x equals x log x, complete the following table. And you can use a graphing calculator. You don't have to have a graphing calculator to do these problems, but you can use one if you want to. So first, notice we have x equals 1, 1.5, 2, blank, 3, 3.5, 4, 4.5. So when it says complete the following table, that just means fill in the missing blanks with numbers. What number goes here? What number goes there? So just look at the pattern in the x values, and you can see that a must be 2.5. It's not going to be like 2.8999 or something weird like that. I mean, it's a consistent pattern there, so just recognize that. That's all you have to do. For B, really all we need to do there is we've been given the input of 3.5, so what would the output be? So that would be 3.5 log times log 3.5. So get your calculator out and do 3.5, hit the log base 10 button there, times that by 3.5, and you get 1.90. So we'll just say 1.90 for B. And that's it. Now, because it's good to know how to do this on a graphing calculator, also we could just go ahead and here's the TI Inspire graphing calculator. We would type in x and then make sure and hit the times symbol, and then we want to do log base 10 of x. Hit enter and we see that graph there, and then we go to menu, table, split screen table, and we see a table appear there. Now that we have the table, we can go back to menu, table, edit table settings, and we could select a table start. So let's start it at 1, just like our table in the problem has, and then let's do a table step. This is basically our delta x is what that means. You might want to make a note of that. That's delta x. What is our change in x? Well, it's changing by 0.5 each time, right? So it goes 1.52, 2.5, 3, and so on. And that's all we need to do on there. We don't need to worry about the independent and dependent. Just leave those like they are as auto. Hit OK. And look, we get that table. And we can just scroll through the table now. And what was the value? We wanted the output at 3.5 when x is 3.5. And there it is right there, 1.90. Just like we got doing it manually on a regular calculator. You might also notice our answer for A was 2.5. Notice that matches our table in our problem. The output matches of 0.995. So make sure you understand you didn't have to have a graphing calculator to solve this problem, but it's good to know how to create a table from your data, and then you can see right there you have the graphical form and the tabular form right next to each other. And you can even move this around and you can see the symbolic form as well. Look at problem 2. Given the following table, which value of x best represents the local max for the function g of x. So we see input x, output g of x, the local max. So we're looking for a peak output. Where is the peak output? Well, just look through them there. We see 0.16, 0.57, 1.1, 1.6, 1.8, 1.6. This was a peak, right? Just keep going just to look. 0.94 minus. So there it is right there. So the value of x that best represents the location for the local max, the value of x would be x equals 2.0. So that's normally how we identify local maximums and minimums. Extrema is where is their x location. So pretty easy problem. As long as you answer it correctly, find the x value. We don't want what g of x equals there. We want what the x value is at the maximum. Let's do one more. The graph of the function f and a table of values for the function g are shown. So we see some different composite types of functions and operations as well, f plus g of 1, that we want to find out here. So we have a numeric form and a graphical form. Be careful about identifying which one is which here. So we can clearly see there that the table is g of x. And the graph, it says x versus y. So if you want to, you might want to just say f of x right there, just so you eliminate some confusion maybe and doing the wrong ones. For a, we want to know what f of g of 3 is. So, well, what is g of 3 equal? Well, look at the table. G of 3 equals 5 from the table, right? So what we want to find then is f of 5. So when x equals 5, we would move over to the right 1, 2, 3, 4, 5 up to the graph. That's at 1. Assume these are simple integer results here. We're not looking at 1.001 or something weird like that there. Just the output is 1. That's your answer. F of 5 is 1. For b, we want to know g of f of 3. So what is f of 3? Don't use the table. Use the graph this time. So let's erase our previous marks on there. And so we'd go to the right 1, 2, 3. We're going to go down this time to get to the graph. We'd go down 1. So that means f of 3 is equal to -1. G of f of 3 means we want to find g of -1. Look at the table. When x is -1, g of x is 4. G of -1 is 4. And that's it. For c, f plus g of 1. So we want to know what f of 1 plus g of 1 equals. Well, look at the graph for f of 1. And that means we'd go to the right 1, and then we have to go down to get to the graph, down 1, 2. So f of 1 is -2 plus g of 1. G of 1 on the table, g of 1 is 1. -2 plus 1 is -1. And that's the answer there for that operation. And that is all for Lesson 40.